Good morning, welcome to the session. See, in this session, we are going to study the different factors which influences rate of a reaction or different factors which affects rate of a chemical reaction. Now, what are the different factors which influences rate of a reaction? See, mainly there are three different factors. Mainly there are three different factors which influences rate of a chemical reaction. They are one is concentration of the reactants. Second one, it is temperature. Third factor, that is catalyst. So reaction rate, mainly it is affected by three different factors. They are concentration of the reactants, temperature, catalyst. Now let us study one by one. Now what is the effect of concentration on the reaction rate? See, effect of concentration on the reaction rate can be studied by using a law. That law it is called this law it is called as what? Law it is called as law of mass action. Law of mass action. So effect of concentration on the reaction rate, it is studied by using a law. This law it is named as law of mass action. Now according to the law of mass action, according to what? According to the law of mass action, at a constant temperature, at a constant temperature, reaction rate it is directly proportional to molar concentration of the reactant. I will repeat it once again. According to the law of mass action, at a constant temperature, reaction rate it is directly proportional to molar concentration of the reactant. What does it mean? With the increase in the concentration, reaction rate also increases. So here we can explain effect of concentration on the reaction rate. So what is the effect? At a given temperature, rate of the chemical reaction directly depends upon either one of the concentration of the reactant or any one of the product. Okay, so at a given temperature, reaction rate mainly depends upon what? Either concentration of a reactant or concentration of a product. Now, we can represent the reaction rate. We can represent what? Reaction rate by taking concentration of the reactant, and that expression it is called rate law. That expression it is called as what? Rate law. It is also called as rate expression. It is also named as what? Rate equation. So rate law means expressing the reaction rate by taking what? By taking concentration of the reactant or concentration of the product. This law it is called as what? Rate law, rate expression or rate equation. Now let us consider one general reaction. Let us consider a general reaction where reactants A and B, they'll react to produce what? To produce products C and D. Here, small letter A and small letter B represents stoichiometric coefficients of reactants A and B, whereas small letter C and small letter D represents stoichiometric coefficients of the products, that is C and D. Now, according to the law of mass action, what I can write? See, rate, that is reaction rate, it is directly proportional to molar concentration of the reactants, that is concentration of A into concentration of B. According to what? According to the law of mass action, rate it is directly proportional to concentration of A into concentration of B, and their powers, I'll write it as X and Y. We don't know the values of X and Y. So, rate it is directly proportional to concentration of A power X, concentration of B power Y, where X and Y X and Y, they are what? They are exponents. X and Y, they are exponents. Now, values of the exponents X and Y either may be equal to stoichiometric coefficient or may not be equal to stoichiometric coefficient. So, it can be equal to A or B, or it may not be equal to A or B, that is stoichiometric coefficient. Now, what I will do is, I will remove the proportionality sign. On removing the proportionality sign, we have to add a constant, correct? So, rate it is equal to K into concentration of A power X, concentration of B power Y. Concentration of A power X into concentration of B power Y, where X and Y, they are what? They are exponents. X and Y, they are exponents. Their values, they are obtained from the experimental data. It cannot be predicted by looking at the balanced chemical equation. It cannot be predicted by looking at the balanced chemical equation. Their values, they are always obtained from what? From the experimental data, that is by studying effect of concentration on what? On the reaction rate. See, this expression can also be written in differential form. That is minus dr by dt. Now, what is this dr by dt? Change in the concentration of the reactant with respect to time. So, change in concentration with respect to time, this is rate only. So, minus dr by dt, it is equal to K into concentration of A power X into concentration of B power Y, and this expression, it is called as what? Differential rate equation. What is this? Differential rate equation, whereas K proportionality constant, K, it is called what is it? K, it is rate constant, or it is also called as velocity constant. K, it is rate constant or velocity constant. Okay, we shall repeat it once again. So, in the beginning, I told you about the factors influencing rate of a chemical reaction. Rate, it is mainly affected by three different factors. They are concentration of the reactants, temperature, third factor, it is catalyst. Next we went to effect of concentration on the reaction rate. Effect of concentration on the reaction rate, it is given by a law. That law it is called as what? Law of mass action. What does it say? Law of mass action. At a given temperature or at a constant temperature, reaction rate, it is directly proportional to concentration of any one of the reactant or any one of the product. Now, we can represent the reaction rate by taking concentration of a reactant or by taking concentration of the product. This expression it is called either rate law or rate expression, or it is what? Or it is rate equation. In order to explain this, we took a general reaction, that is A and B, they are reactants. They will react to produce what? To produce the product C and D. Here, small letter A and small letter B represents stoichiometric coefficients of reactants A and B, whereas C and D, these are the stoichiometric coefficients of what? The products C and D. Now, according to the law of mass action, what we can write? Rate, it is directly proportional to concentration of A, power it is X, concentration of B, power it is Y, where X and Y, they are called as what? They are exponents. They are what? They are exponents. Their values, it is always obtained from the experimental data. So, values of X and Y may be equal to stoichiometric coefficient, may not be equal to stoichiometric coefficient. On removing the proportionality sign, we got rate equal to a proportionality constant, that is K, into concentration of A power X into concentration of B power Y. Same equation can be written in differential form also, that is minus dr by dt. It is equal to K into concentration of A power X into concentration of B power Y. See, this is rate law. What is this? Rate law, or it is rate expression. It is also called as rate equation. Since it is in differential form, it is named as what? Differential rate equation. Differential rate equation. This is rate law. This is also rate law only, but it is in differential form. So, this is differential rate equation. Proportionality constant K, it is called as what? It is called as rate constant, or it is velocity constant. Next, we are going to define the term rate law. We are going to define the term rate law. Now, what is rate law? See here. See, this is rate law. This expression, it is called as what? It is called as rate law. What we can see here in our rate law, rate it is proportional to what? Rate it is proportional to concentrations of the reactant. I will define it. Rate law. See, rate law, it is an expression. It is what? It is an expression. In this expression, reaction rate, it is expressed in terms of concentrations of the reactants. I will repeat it once again. It is an expression in which reaction rate is expressed, or reaction rate is given in terms of what? In terms of concentrations of the reactants. Reaction rate it is expressed, or it is given in terms of concentrations of the reactants. With each concentration term, there are two different concentration terms here. With each concentration term raised to some power. Raised to what? Raised to some power. You can see here X and Y. So, each concentration term raised to some power whose values can be equal to stoichiometric coefficient or may not be equal to stoichiometric coefficient present in a balanced chemical equation. Present what? Present in a balanced chemical equation. Repeat. So, rate law, what is rate law? Rate law, it is an expression. This is the expression. In this expression, reaction rate is expressed, or reaction rate is given in terms of concentrations of the reactants. with each concentration term raised to some power. Concentration term raised to some power, which may or these powers may or may not be equal to stoichiometric coefficient present in a balanced chemical equation. This expression it is called rate law, or it is rate equation, or it is rate expression. I will write the definition here. Rate law what is rate law? It is an expression in which what is given in that expression reaction rate is given. Reaction rate is given in terms of reaction rate. It is expressed in terms of what? Concentrations of the reactants with each term raised to some power. Each term raised to some power which may or may not be equal to stoichiometric coefficients in a balanced chemical equation. In what? In a balanced chemical equation. So what is rate law? It is an expression. In that expression, reaction rate is expressed. Reaction speed is expressed by taking concentrations of the reactants with each term, each concentration term raised to some power. Value of that power may or may not be equal to stoichiometric coefficients present in a balanced chemical equation. This expression it is called as rate law, or it is rate expression, or it is rate equation. Remember, rate law for a given chemical reaction, cannot be obtained just by looking at the balanced chemical equation. Rate law cannot be predicted by looking at the balanced chemical equation. It is always obtained from the experimental data. Rate law it is always obtained from what? From the experimental data. It cannot be obtained from the theoretical data. We can give an example for this. See, let us consider one reaction. Let us consider the formation of nitrogen dioxide, that is NO2. We can write the equation. NO, nitric oxide, combines with oxygen forming nitrogen dioxide, that is NO2. We can balance this equation. It is 2NO, 2NO2. I will write down the experimental data here. This is first trial number 1, 2, 3, 4. This is initial concentration of NO, initial concentration of NO. Other reactant, that is initial concentration of O2. Last column, that is initial rate of formation of NO2. I will write down the values here. I will take the initial values as 0.3 and 0.3. Rate it is found to be 0.096. Rate of formation of NO2, it is equal to 0.096. In the next trial, I will take concentration of NO as 0.6, concentration of O2 as 0.3. Rate it is found to be 0.384. Next trial, I will take it as 0.3 and 0.6. Value it is found to be 0.192. Last one, I will take it as 0.6 and 0.6. Value it is found to be 0.768. We shall study these experimental values. See, this is the given reaction, that is formation of NO2. NO combining with O2 forming NO2. We can write the expression for this reaction like this. See, rate equal to K into concentration of NO power X, concentration of O2 power it is Y. I will name it as equation 1. Concentration of NO power it is X, concentration of O2 power it is Z, power it is Y. We don't know the values of X and Y. What are X and Y? X and Y, they are exponents. Values of the exponents always it is obtained from the experimental data. It cannot be obtained from the theoretical data. Okay. See the first trial. In the first trial, when the concentration of NO, when it is equal to 0.3 and concentration of O2, it is equal to 0.3. Concentration of NO, it is equal to 0.3. Concentration of O2, it is equal to 0.3. Rate, it is equal to 0.096, that is mole per liter per second. Value it is found to be 0.096. See the second trial. See, concentration of NO, now it is equal to 0.6. It is equal to how much? It is equal to 0.6. 0.6 means concentration of NO has been doubled. Concentration of NO, it is doubled. Concentration of O2, it is retained as it is. Concentration of O2, it is retained as it is. Now, rate it is found to be 0.384. 0.384. See here, there is change in the concentration of NO. There is no change in the concentration of O2. So, rate law can be written like this. Rate equal to K into concentration of NO power it is X. No need to write the concentration of O2 because rate does not depend upon concentration of O2 because there is no change in the concentration of O2. We know that rate will change only there is a change in the concentration. So, in the second trial, there is a change in the concentration of NO. There is no change in the concentration of O2. So, rate will depend only on the concentration of NO. It will not depend on the concentration of O2. So, rate it is equal to K into concentration of NO power it is X. See, in the second trial, concentration of NO, it is double, correct? Initially it was 0.3, now it is 0.6. So, concentration of NO, it is double. I will write it as 2 here. So, 2 to the power X. So, when the concentration of NO, when it is double, rate has been increased by 4 times, correct? 0.096. This is the initial value. Now it is 0.384. So 0.096 into 4 into what? Into 4. It is equal to 0.384. So when concentration of NO, when it is double, rate increases by what? Rate increases by 4 times. That means value of x, it must be equal to how much? It must be equal to 2. So 2 to the power 2, it is equal to what? It is equal to 4. Now we got the value of x. So value of x, it is equal to 2. Value of x, it is equal to what? It is equal to 2. Similarly, we can calculate the value of y also. See, I will take the third trial. See, the third trial, concentration of NO, it is retained as it is. Initially it was 0.3, now it is also 0.3 only. Now what about concentration of O2? Concentration of O2, it was 0.3 in the beginning, now it is 0.6, that is concentration of O2, it is doubled. Concentration of NO, it is retained or it is kept constant. Concentration of NO, it is kept constant. Concentration of O2, it is double. Rate value, it is found to be 0.192. Rate value, it is found to be how much? It is found to be 0.192. So in this trial, we can see here, there is a change in the concentration of O2. There is no change in the concentration of NO. So rate depends only on concentration of O2. It does not depend upon concentration of NO. Why? Because there is no change in the concentration of NO. So rate will not alter. Because of what? Because of NO. So rate will change only due to what? Due to the change in the concentration of O2. So concentration of O2 has been doubled. I can write it 2 here. What about rate? When the concentration of O2, when it is doubled, initially it was 0.096, now it is 0.192, that is 0.096 multiplied by 2, it is equal to 0.192, correct? So when concentration of O2, when it is doubled, rate also increases by what? By a factor of 2. So then what is the value of y? Value of y must be equal to how much? It must be equal to 1. So 2 to the power 1, it is 2. So value of x, it is 2. Value of y, it is 1. So values of the exponents, it is obtained from what? From the experimental data. What about the last trial? You can see the last trial, fourth trial. See, concentration of NO, it is double. Concentration of NO, it is double. Compare this value with the first one. Concentration of O2, it is also double. Concentration of O2, it is also double. When both concentration of NO as well as concentration of O2, it is double, rate of the reaction, initially it was 0.096, now it is 0.768. 0.768. That means 0.96 must be multiplied by 8. On multiplying by 8, we will get 0.768. So rate increases by 8 times. Rate increases by what? 8 times. So it must be 2 to the power 3. Must be what? 2 to the power 3. This can be written as 2 to the power x plus y. X plus y must be equal to 3. That is correct. See, x equal to 2, y it is equal to 1. So when concentration of both the reactants are double, rate of the reaction increases by 8 times. Increases by what? 8 times. So rate law for this reaction, it is found to be what? Rate equal to K into concentration of NO. I can write power it is 2. Concentration of O2, power it is 1. Power it is 1. So this is the rate law for the formation of what? Formation of NO2. So rate law for a given reaction cannot be written just by looking at the balanced chemical equation. It is always obtained from what? From the experimental data. See, if you go for the chemical reactions, there are two different types of chemical reactions. One is elementary reaction, other one is complex reaction. So reactions are of two different types, elementary and complex. Now what do you mean by elementary reaction? Reaction taking place only in one step. Reaction taking place only in one step. Such a reaction it is called elementary reaction. Whereas complex reaction means reaction taking place in sequence of steps or number of steps. So sequence of steps, or I can say sequence of elementary reaction. Sequence of elementary reaction represents what? Represents complex reaction. When sequence of elementary reactions gives rise to products, sequence of elementary reactions give rise to products, then such a reaction it is called complex reaction. Such a reaction it is called as what? Complex reaction. See, in that sequence of reactions, maybe there are four different reactions in the mechanism. Sequence of elementary reaction we call it as mechanism. So in a complex reaction, number of steps will be involved. In those steps, one of the step will be very slow. One of the step will be what? Will be very slow. So slowest step in a complex reaction, slowest step of a complex reaction, it decides the reaction rate. Slowest step of the complex reaction decides what? Decides the reaction rate, and this slowest step of the complex reaction, it is called rate determining step. Rate determining step, RDS. RDS means rate determining step. So what is RDS? RDS it is nothing but rate determining step. Rate determining step means slowest step of the complex reaction which decides the reaction rate of a complex reaction. So slowest step always decides the rate of the complex reaction. That step it is called rate determining step. Slowest step it is named as what? Rate determining step. And to this rate determining step or to this slowest step, rate law it is written. Rate law it is written. Hope it is clear. Thank you.